All right, so we have a object here. We're pushing this 45 kilogram block for 10 meters across a frozen lake. So that's the displacement with a force of 300 newtons as shown. The coefficient of kinetic friction is 0.03. How much work is done by the contestant on the block of ice? Okay, so we do the free body diagram. It's kind of how we're going to, because we want to do the force and the displacement. We know the displacement is to the right. So our goal is to find all of the forces and see which ones are parallel and things. So when we do our free body diagram, we have gravity, 45g. We have a surface here that exerts two forces, a normal force perpendicular to that surface and some frictional force. What kind of friction? Kinetic friction. And then we have this force down and to the right, acting in that direction at an angle of 25 degrees. Okay. Now, we know the displacement is to the right, so we want to decompose any of the forces to be parallel and perpendicular to the horizontal axis. And so this is going to be F cosine 25 degrees and F sine 25 degrees. Now, in terms of work being done on the block by the contestant, that is the work done by this force F here. Okay? What do we want to think about is we want to think about what force is parallel to the displacement. Well, the displacement's to the right, and the F cosine 25 degrees is to the right. They're both to the right, so the work would be positive, and it's just going to equal the component of that force times the displacement here, which is 300 cosine 25 degrees times 10. Okay? And that's going to be 2,720 joules. Okay, that's A. B, what is the work done by gravity? Gravity is pulling downward. It is perpendicular to the displacement to the right, so that work is 0. What is the work done by the normal force? Well, again, the normal force, perpendicular to the displacement, that work is also 0. What is the work done by friction on the ice? Well, the frictional force we have to figure out is equal to mu times the normal force. So it is parallel, but it's opposite the direction of the displacement because the displacement's to the right and the friction's to the left. So it's going to be negative work, but we need to know what the frictional force first is. It's 0.03 times the normal force. Now, what is the normal force? Here we're going to have to do F net equals ma in the y direction to decide what. So let's say up is positive. So we'd say Fn is positive. 45g is negative. F sine 25 degrees is also negative. And that equals 0. So the normal force is going to equal 45g plus F sine 25 degrees. That's going to equal 45 times 9.8 plus 300 sine 25 degrees. And so let's see what that gives us. 45 times 9.8 plus 300 sine 25. That's going to be 568. And so our frictional force is 0.03 times 568. And I get about 17. And so the work done by friction is going to be negative. Okay, why negative? Because the frictional force is opposite the direction of the displacement. Displacement's to the right, friction is to the left, so it's negative 17 times 10, which would be negative 173, negative 170 joules. Okay, negative 170. All right, what is the net work done? Now you just add up the work all by the forces. So it's going to be 2720 plus 0 plus negative 170. You're just doing the work done by every force, which we did F, we did Fn, we did force of friction, we did the 45g. That all adds up to 2550. Now the contestant pulls the block of ice with the rope over his shoulder at the same angle above the horizontal with the same force as shown. How does the net work apply to the block in the ice situation compared to the previous one? Well, let's think about the free body diagram and let's think about all the forces that are acting. We still have mg, we still have Fn, and we still have a frictional force. But our force up at an angle like this instead. Now, this is still 25 degrees. And so when we decompose it, the F cosine 25 degrees and F sine 25 degrees. Now the displacement is still to the right. And the F is still 300, still same 300. So this force is the same, the normal force is the same, mg is this, well, so the normal force is not the same. But the work done by the normal force, so the work done by F is the same. The work done by the normal force equals same, which is 0, because it's still perpendicular to the displacement. Work done by gravity equals the same, which is 0. How about the work done by friction is smaller, is less negative. Why is it smaller? It's because the force of friction is mu times the normal force. And the normal force is actually going to be smaller. If you think about, like, if you do F net equals ma in the y direction, and we say up is positive, now you're going to have Fn plus F sine 25 degrees minus mg, because now the F sine 25 degrees is upwards instead of downwards. And this equals 0 because there's no vertical acceleration. So if you look at the Fn, it's mg minus F sine 25 degrees. So this is smaller, which makes this smaller. So the work done by friction is actually less negative or greater because it's closer to 0. So actually the work done applied to the block, the net work is going to be greater because there's going to be a smaller negative work by friction. Okay.